Hello, everyone. Good to see you all. This is usually when my kids give me a call through my wife's phone, but the good thing is they're in the audience today. I love the three of you a lot. We are here to talk about AI-enabled explainers for observability. When I say we actually did something with AI, it doesn't mean that we're the only ones who have done something, but if you have listened to my talks in the past, I'm big on storytelling, and over the next 10 to 15 minutes, I'm going to tell a story about how we came up with the concept of explainers and how we are using it right now and where we see it go in the future. I keep saying we. Who are we? We are eBay. eBay today is present in 190 markets with 2.3 billion live listings, 134 million active buyers worldwide, and the volume of money we transact just on mobile devices is roughly $13 billion. Who am I? My name is Vijay Samuel. I'm a principal MTS architect for the reliability engineering organization at eBay. My primary responsibilities are around observability, SRE, site operations. And I should say, it's been an absolute blessing for me to be with eBay for around 13 years, and I've been with eBay straight out of college. I'm a big open source enthusiast. Started off with DrizzleDB. Shout out to anyone in the audience who has worked on Drizzle so far. Since then, I worked with multiple communities like OpenTelemetry, Prometheus, and more. Let's start off by saying that observability is intense. Out of the 13 years at eBay, 10 of them I've spent on either logging or monitoring, or now observability, as we like to call it, and the scale of operations has exploded over the last 5 years or so. Complexity doesn't cease to slow down. Within eBay, we have roughly 4,600 microservices that power the actual eBay site, and from a scale perspective, we generate 15 petabytes of logs per day, 10 billion active time series, and 10 million spans per second that's sampled at roughly 2%. So it's not a trivial amount of data that we have to deal with. And so incidents impact our ability to provide the highest quality experience to our customers, and that's what we try to do. The fundamental problem with the site becoming more and more complex is that as humans, we have limits to how much we can comprehend at any given point in time. So if we take manual triage as an example, the time it takes to traverse a very long call chain is a lot. The amount of time it takes to sieve through terabytes worth of logs is a lot. And how many dashboards do I have to look at before I can arrive at a hypothesis? And all of these are trial and error based, and usually there are a lot of errors before we actually land on what is right. So at a time where we were relying on static threshold-based alerts or manually eyeballing things as they fall off a cliff, there was a first pass at innovation, and this was basically machine learning. Shout out to my partner in crime, Huai Jiang, in Shanghai, who spearheaded a lot of this. We first tried to reduce the time to detect to under 4 minutes using anomaly detection. We built something called Groot, which is available as a white paper online, which can attach a root cause to every alert that's triggered off of a business KPI. And we did simple auto-remediation. Say there is a bad pod that's there. If you're able to identify that outlier, maybe bounce the pod. It's a good start, but it doesn't work all the time. And one of the reasons being that it learns based off of what it has seen. And if it sees something new, it does not know what to do with it because there is no reasoning capability. So we expect the machines to do more. And then came the LLMs. They came with a big bang. They could do things like, given human input, be able to comprehend it and do something on top of it. And they can respond like humans, which was fascinating to all of us. We have played with ChatGPT. When I first got my hands on ChatGPT, I asked it, go rewrite the Prometheus postings index to use roaring bitmaps. I tried, and eventually I learned about what hallucination actually meant, and then I gave up on that. So there are problems with AI, and Christine's talk alluded to some of it. But one of the things that when ChatGPT and other LLMs came out, we were like, this is the silver bullet. This is going to solve everything. Just throw engineering out the window. It's no longer needed. AI is going to do everything. We tried to bite off more than we can chew, and there was a lot of randomness that was guaranteed. So everything that we tried, fail some more. And end of the day, we need to realize one thing, that the probabilities need to work in our favor. If we prompt in a very deterministic way, give very crisp context, then it becomes a little bit more deterministic. But if you keep layering more and more probabilistic things into more complicated workflows, like triage the site or triage an alert, then the probabilities are going to work against you, and you're going to get very random responses. And do you want to use those random responses when you're troubleshooting an incident? Probably not. So at that point, we realized that maybe it's worth starting off small. With the current capabilities that LLMs have, what are simple things that we can knock out of the park? And that's when we came to the realization that we need to build what we like to call building block capabilities. Capabilities that are of high quality, highly deterministic, that we can confidently rely on. The first one being a trace explainer. Given a trace ID, pull the spans, analyze, try to find what the causal span is, and then do a summarization on top of it. Do a log explainer. Given a bunch of log lines, analyze them, find if there are any error or latency patterns that are worth investigating, summarize them. Given a metric explainer, given a bunch of time series, analyze them, identify if there are any particular trends that are useful, are there any anomalies, do a summary. And then finally, a change explainer. Given an application making a change, identify what kind of change is being made, and do a summary on top of it. So you can see that summarizing is a very key theme in all of these explainer capabilities that we are building. But this doesn't necessarily eliminate the problems with AI. There are finite context windows that we need to work with. And typically, the data is large. And if you take our checkout API as an example, it has 3,000 spans. And there are use cases that I've seen where we have 8,000 spans per request. So what would happen if you shove all of it into the LLM? You won't be able to fit within the context window. The more data that you try to give to the LLM, the more it will hallucinate over time. And you have more people screaming into the abyss as a result. So shoving everything into the LLM is definitely going to be met with disappointment. And this is when we came to the realization that AI and engineering are in a love-love relationship. And it is important for us to use both AI and engineering for their strengths. And combining their strengths will help us achieve something that is truly magical. So we went back to the basics. Given a trace, what are things that we can do to make sure that we can make things a little bit more predictable? So the first thing that we did was to clean the trace up. How do we clean? Remove everything that's not in the critical path. There is a white paper that Uber did a few years ago called CRISP, which effectively teaches us a good way of generating a critical path. We started off using that and then did some improvisations on top to the point where we had a critical path algorithm that worked for us and eliminated all the spans that are not in the critical path. And after that, we did few short prompting to say that, okay, this is how SREs within the company triage active incidents. An example would be, if it's a 4xx, don't consider that as a heart failure. If it's a 5xx, then you need to pay more attention to that. Then we focus more on self-time, because self-time is where you find truly resource-intensive spans. And then finally, we leveraged LLMs for what they're actually good at, which is to summarize, do simple reasoning, and then explain, specifically the critical path. Another thing that we ended up doing is we dictionary encoded everything. So it's not going to be service name equal to checkout. It's just going to be service name equal to 1. And for all practical purposes, machines don't really need to know if it is checkout or if it is foo bar. It's just going to look at things, analyze, and then spit out responses. So once we have done that, we split the trace into upstream and downstream chunks. We generate partial explanations for all of them. And with the partial explanations, we basically combine them to generate a final explanation of the full critical path. And this helps us to identify if there are any more than one performance issue that we need to be worried about. Then, so assuming that we have these capabilities that are of high quality, we started to layer them together. A good example for that would be a dashboard explainer. Given dashboard metadata that conveys, these are all the time series that need to be painted. These are the annotations that depict changes. These are some of the faulty traces that are worth looking at. Pull all those, use the corresponding explainers, and then try to generate an explanation on top of all of it. And you can take that even a step further to come up with a triage workflow, saying that given an alert, look at a bunch of KPI dashboards, standard dashboards, analyze the KPI dashboard, analyze the standard dashboards, analyze if there are any faulty traces. And one of the things that we did was we had a pipeline stage in the alert manager that embeds faulty traces into the alerts so that the alert has more context for having a meaningful triage, finally summarize all of it. Where did it come handy? So we had an issue where there was a slowdown in database queries with roughly 1,300 spans within that trace. The trace explainer basically came in and said that user segment service has a particular span that is taking a lot of time. This was enough to tell us that this is the service in the call chain that has problems. Then the log explainer basically came in and said that there is a timeout exception that you need to be worried about. And this basically saved our SRE quite a bit of time in identifying what was going on. Otherwise, they would have to manually go to the logs, the traces, find out what's going on. The possibilities are infinite. If you really start thinking about building these things as building block capabilities, there are so many things that you could do. For one, if we had all the metric metadata available on a vector database, you could start writing PromQL, saying that, tell me how many search requests failed in the last 1 hour. If you have an ability to generate PromQL expressions, you can put a few of them and then create a Prometheus rule group. You can ask this, the platform to increase your quota. You can ask, why did I get a particular alert? Why did my SLO violate? And eventually, you can get to a point where you can stack all of these up and say that, help me triage the site for me. We also realized that it's better for us to figure out ways in which we can remove the probabilistic nature of LLMs. And the best way, according to us, is to back them up by APIs. And the critical path algorithm is a good example. If you were to do the same thing for time series, you would probably do it with the anomaly detection under the hood and then providing the responses for the LLM to summarize. Stick to what the LLM is good at. It's good at simple reasoning, summarization. It's good at code generation, things like Copilot, and internal knowledge search through retrieval augmented generation. Many things can still be done with code instead of LLMs, and we should continue doing that. Do not use the LLM just because. What could we do more with? While LLMs can comprehend the wild, wild west, there is a strong need for us to have standardization. We need standardization on the ingest side, and we need standardization on the query side. We need widespread adoption of open telemetry with people following the schema, because that will help us make a lot of assumptions. And we need the same on the query language as well, which we don't have today, and natural language is frankly not the answer. Chris Larson, one of the co-chairs for the query language standardization group of the Observability tag, has a talk later in KubeCon. I strongly encourage everyone to participate and take part in that conversation. Are we on the right path? Sure. It's a lot of work that was put in by the team to get this done. We strongly believe that we are in the right direction. But will I change my stance in the next KubeCon? Maybe. The space is so rapidly evolving that if I walk down the stage, something new would have come up and it would all be irrelevant. If you have any questions, I'll be at the OpenTelemetry Observatory a few minutes after this talk. Happy to have a conversation. And thank you very much.